So you found the skeleton. How would you tell people that you personally? How would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there YouTube, the Dapper Dinosaur here. I am announcing a cool project. If you've been paying close attention to my live streams, you may have heard about this, but if you haven't, then this may be news to you. I'm going to be doing a collaborative speculative evolution project, and this is going to be the announcement for Phase 1. In Phase 1, we are at this planet's rough equivalent of the Precambrian, but just the very late Precambrian. We haven't quite got to the point where predation is a big enough problem for creatures to develop spines or shells or really complicated defense mechanisms, but we are at the point where eyes are fairly common. And so at this point, I'm accepting almost anything that people come up with that meet the criteria that I think are reasonable for an late Precambrian period. So basically, we're at the point where the very, very basic body plans of subsequent organisms are being developed. And in this video, I'm going to go through what we already have developed for this stage. And then as time goes forward on the planet, once this stage ends, which will be fairly soon, from then on any subsequent submissions for this project have to be based on organisms that already exist. The next stage is going to define a world map that will shift over time, and will bring the timeline up 10 million years, and there will be the advent of predation. From that point on, we're going to go in somewhat irregular time periods, where the continents will shift, and there will be occasional, and not previously hinted at, mass extinctions. So if you have your favorite critters running around on the planet, they may go extinct. But then after the extinction, we will pick up with the survivors, and we can have new radiations of previous groups. Without further ado, let's go through the planet itself, as well as the first few organisms that we have established for it. The robotic Alcubierre drive-equipped probe, Al-Barak, discovered a life-bearing world with macroscopic alien life in 2693. There is no evidence of sapient life, and a human research outpost was put in orbit. It was named Alma Asia by its discoverers. Here are the important statistics. Semi-major axis, 0.82 AU. Orbital eccentricity, 0.0158085. Year length, 0.796 Earth years, or 337.61 local days. Orbital inclination, 6.302 degrees to the star's equator. Axial tilt, 25.1 degrees. Mass, 1.41 Earth masses, or 8.421 times 10 to the 24th kilograms. Radius, 1.24 Earth radii, or 7,881.44 kilometers. Circumference, 46,495.8 kilometers. Mean density, 5.470 grams per cubic centimeter. Surface gravity, 0.917 Gs, or 8.993 meters per second squared. Day length, 20 hours, 47 minutes, 2.4 seconds. Atmospheric pressure at sea level, 1.2 atmospheres, or 1,292 torr, or 25.0 psi. Atmospheric composition, 0.05% water vapor, 75.08 nitrogen gas, 23.1% oxygen gas, 1.05% argon, 0.05% carbon dioxide, 0.06% krypton, 0.05% xenon, and 0.01% other trace gases. The star it orbits is a spectral type G8V main sequence star with a mass of 0.87 solar masses, a diameter of 0.90 solar radii, a surface temperature of 5,385 Kelvin, a luminosity of 0.57 solar luminosity, and a habitable zone between 0.72 and 1.0 AU. Next, I'll describe some of the organisms that have already been created for this project. I will do this in alphabetical order. The first organism was designed by Benthoven, no relation. Bobbert is a shallow water dwelling creature that feeds on basiorhizoid, tiny worms, and anything else it can find in the substrate. It ingests substrate occasionally for small prey, and a cloaca passes waste and indigestible matter. While it may bear a superficial resemblance to tetrapods of Earth, its anatomy is quite different. Bobberts have 4 walking legs, a mouth, and a pair of chemoreceptors anterior to the mouth. Both the mouth and the chemoreceptors sit on the ventral side of the snout. Lateral to the snout are 2 feelers. Its mouth hole sucks up food and the cloaca spits out indigestible soil. Internal anatomy includes a rudimentary brain, no lungs, Gas exchange is from the tail, which has tiny structures similar to villi except they exchange gas, not nutrients. Bobbards have an open circulatory system. They have smooth muscle that forces blood throughout their body, and this hydrostatic pressure is also responsible for moving the limbs. Hemocyanin-based blood gives a bluish hue to the creature. It also has a small amount of melanin, so its skin has some resistance to radiation. Although living underwater, not much is needed. It also has 2 eye spots posterolateral to the snout. Bobbard is a hermaphroditic organism with 4 paired gonads all connected to the cloaca. The anterior pair produces female gametes and the posterior pair male gametes. Mating occurs with the dominant partner laying eggs that are then externally fertilized. Dominance is established by a wrestling match. Bobbard consumes microbes from soil as well as eating Bossio rhizoid. They can be found wherever Bossio grows. Bobbard has rudimentary eyes which can barely detect light. They help it differentiate deep water from shallow water. The, quote, nose smells the food which is dug up from the ground. Scientific name? Carulicanus porcus. Ancestry? Pseudotetrapoda. Lifespan? 2 local years. Average height? 0.1 centimeters or 0.4 inches. Average length? 1 centimeter or 0.4 inches. Next up is Bossio, creature designed by Bent Hovind, no relation. Bossio is a photosynthetic organism from the ancient seas of Alma Asia. Bossio has 3 major sections, the leaf, stem, and the rhizoid. The leaf is a circular structure with simple vascularization that transports sugars from the leaf to the rest of the organism, and it is the primary photosynthetic organ. The stem is a structural support helping the leaf reach sunlight in the shallow seas. The rhizoid is responsible for uptake of minerals from the substrate, anchoring the rest of the organism and sending up new stalks. The leaf is also a reproductive structure. Photosynthesis is performed by a combination of retinol on the surface of the cell membrane under a cell wall of peptoglycan, and a purple pigment similar in function to chlorophyll. Retinol is used to help drive ATP metabolization, while the other energy derived from photosynthesis goes towards producing sugars. Reproduction is asexual, by new stalks being sent up the rhizoid, as well as releasing reproductive cells to the center of the leaf, which are then carried away by currents, to hopefully land in shallow water with enough nutrients in the substrate and enough sunlight to support photosynthesis. It takes about 80 hours to reach the maximum size for a new stalk on the rhizoid, assuming optimal growing conditions. New colonies spread by dispersion usually take about 120 hours to get their first stalk to full size, and then the first new additional stalks will start growing some 60 hours later, and be full size in a further 160 to 170 hours. Bossio is a primary producer and the base of the food chain, all the way through the shallow waters of Alma Asia. It can be found worldwide. While the organism has no neurons, it can and does turn its leaf to approximately face the sun, although the range of motion is very limited. Scientific name? Phytomycocyclos. Origin ancestry? Retinal phyta. Average height? 2 to 3 inches or 5 to 7.6 centimeters. Like all retinophytes, Bossio is a vibrant purple. The next organism is Cecilia, designed by Duke Ellington. Cecilia is a photosynthetic creature with limited motility and the ability to sense light levels. It has no circulatory or digestive system, but it does have a rudimentary nervous system with a central ganglion. Cecilia can be found worldwide. They have no intelligence at all, they cannot learn, and only react to stimuli in pre-programmed ways. Origin? Phytozoa. Average height? 2.5 centimeters or 1 inch. Average length? 51 centimeters or 10 inches. Due to the presence of chloroplasts, these creatures are green, being brighter in the center of the body and darker going distally. Next up is the feather barrel, designed by the Dapper Dinosaur. The feather barrel was a sessile filter feeder on the planet Alma Asia. Feather barrels are pentaradial filter feeders. They have 10 feeding fronds on the dorsal side, surrounded by a central mouth. They have 5 simple eyes, 5 water intakes between the tentacle ring and the central stomach. Each of these lead to an outlet near the middle of the animal. Each outlet also has a paired set of gonads that release spermatozoa and the ova during spawning. These water channels also help draw food towards the mouth, as well as bearing internal cilia that are the primary surface for gas exchange. The 2 tentacles closest to each eye are controlled by a single ganglion, which also receives signals from the eye. At the bottom of the animal are 5 tentacles that exist primarily to anchor the animal to the substrate, usually a rock. These tentacles are nearly non-existent in larvae, but grow as they transform into adults. The central stomach is blind and undigested material is periodically ejected from the mouth. This is accompanied by a reversal of water flow through the water passages to help clear the waste. About halfway between the bottom of the creature and the water outlet is a simple 2-chamber heart that pumps hemoglobin-based blood through veins and arteries. Feather barrels are diploid hermaphrodites that have quite distinct gametes. They broadcast spawn about every other full moon, although if times are lean for a particular organism, it may forego spawning as it conserves resources. They have 4 distinct life stages. One is a free-floating sphere of cells. This in turn turns into larval stage 1, where the animal is essentially a microscopic member of the zooplankton, and many are in fact eaten by feather barrel adults during this stage. During this stage, they primarily eat embryonic phytozoans or single-cell retinophyte relatives. Assuming they grow large enough to swim against the current, they enter larval stage 2. At this point, they swim down and search for a rock. When they find one, they settle down onto it, mouth up, and secrete a glue. Then they start growing their tentacles to adult proportions and start feeding and growing isometrically, and usually begin spawning on their second year of adulthood. Feather barrels live in shallow to medium depth water, becoming less common away from the tropics. Feather barrels are very sensitive to water currents, and they have some basic image forming ability, allowing them to push away things that are too big to eat, or wave their feeding fronds towards things small enough to eat. The feeding fronds also have substantial chemosensitivity, and they will wipe off things that seem inedible to avoid filling up the stomach. Scientific name? Plumoris rosier. Origin? Xenoradiata. Average height? 7.5 centimeters or 3 inches without feeding fronds. Last but not least, we have Xenoeule kirbii, creature designed by the Dapper Dinosaur. Xenoeule kirbii is an extinct organism from Alma Asia. It is typical of what is assumed to be the ancestor of all other members of its phylum. Xenoeule kirbii was a segmented creature with bilateral symmetry. Each segment is more or less identical, containing a set of ventral paired gill fronds, lateral swimming appendages, and dorsal eyes. Inside the coelom exists a digestive tract, an open circulatory system using hemocyanin, paired gonads, and ventral nephridia. There is a ganglion along the anterior end of each segment, which sends nerves down the lateral side to connect to each appendage, and then back to the next segment. The last segment contains a posterior anus, through which gametes and waste are expelled. Xenoeule kirbii are sequential hermaphrodites. They fed by ingesting sediment from the ocean floor and digesting microbes and small burrowing fauna, then passing the inorganic material and undigested portions of their meals. The eyes of Xenoeule kirbii are primitive and have poor resolution. They can tell whether there is light and which direction it is coming from, but little else. The skin is covered in nerves that allow the creature to sense pain, pressure, and temperature. Origin? Xenosegmata. Average length? 5 centimeters or 2 inches. Alright, well that does it for the creatures that have already been described for stage 1 of this project. If you have any, I am looking for somewhere around 6 more. They can be primary producers, they can be filter feeders, they can be herbivores. No macropredators yet, we're going to wait for the second phase of this project. If you would like to submit anything, you can send me an email or a DM. Please include a sketch, a description, some details about the anatomy, and anything that you find interesting about the biochemistry. Chances are I will approve it, and if I do, I will add it to the World Anvil page. The World Anvil page is where you can keep up on new organisms, new locations. There will be new art uploaded there. All that will be done as it gets finished by me. Not all of the creatures will get full 3D models like you've seen here, but some of them will, and I will be going through and adding them somewhere around once a week or so. The World Anvil page also has background information about the rest of the universe in which this project is taking place, so please go check it out. The link will be in the description, as well as the pinned comment. If you want to email me, my email is the.dapper.dinosaur.yt@gmail.com, and if you want to DM me, my Twitter is @dinosaur_dapper. If you liked this video, don't forget to hit like, and if you haven't subscribed already, please do so. I'm the Dapper Dinosaur.
Thanks for watching. But before you go, I'd like to take some time to thank my patrons, especially my $20 and above patrons: Ian Chen, Chris Love, Henry Hutanen, Bob Knob, The Evil Scotsman, and Bent Hovind. As you know, YouTube is a very volatile platform, and my patrons give me much needed stability. If you'd like to join the team, there's a link in the description to my Patreon, which starts at $1. If you'd like, I also have a link to my Teespring store and an Amazon wishlist.
So you found the skeleton. How would you tell people that this is? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.